Hi, Dr. V. I'm going to be doing extra credit number 2. So the question asks, one of the chymotrypsin inhibitors is a red dye. A solution containing 1 times 10 to the negative 4th molar chymotrypsin and 2 times 10 to the negative 3rd total dye has an absorbance in a 1 centimeter cell at 280 nanometers of A is equal to 1.4. The reaction is protein plus dye makes complex back and forth. The molar absorption coefficients at 280 nanometers are extinction of the protein is 12,000 per molar per centimeter. Extinction of the dye is 0. Extinction of the complex is 15,000 per molar per centimeter. And it's asking to calculate the concentration of the complex in solution. So, to do that, we're going to use the Beer-Lambert law, which is absorption is equal to the extinction coefficient times the concentration times the length. Now, we're going to need to use a modified form of this since we have 3 compounds, and that's going to be this right here. The extinction of the protein, concentration of the protein, plus the extinction of the dye, the concentration of the dye, plus the extinction of the complex times the concentration of the complex, and the whole thing is being multiplied by the length of the cell. So I'm going to write my givens. The concentration of the protein is 1 times 10 to the negative 4th molar. Concentration of the dye is 2 times 10 to the negative 3rd molar. The absorption at 280 nanometers is 1.4. Length of the cell is 1 centimeter. Extinction coefficient of the protein at 280 nanometers is 12,000 molar per centimeter. Extinction coefficient of the dye is equal to 0. Extinction coefficient of the complex is equal to 15,000 per molar per centimeter. So, all I have to do now is plug in all the numbers and solve for the concentration of the complex right here. So I'm going to do that right now. 1.4 is equal to 12,000 times 1 times 10 to the negative 4th plus 0 times 2 times 10 to the negative 3rd plus 15,000 times the concentration of the complex that we're looking for. Everything being multiplied by 1 centimeter. So this just becomes 0. I'm going to rewrite this with out the centimeters since it's getting multiplied out. Okay, so now with that out of the way, I'm just going to start solving. So once I calculate these numbers, what I'm going to get is, let me just put in my concentration right there. Once I plug in these numbers, I get 1.2 right here. The molar units cancel out. And then here, I still have my 15,000 per molar times the concentration of the complex. Here I'm going to subtract 1.4 minus 1.2 is 0.2. That's equal to 15,000 per molar times the concentration of the complex. I subtract this, I divide this to get the concentration of the complex, which ends up being 1.33 times 10 to the negative fifth molar. And that's going to be my answer for the concentration of the complex. Thanks, Dr. V. Have a good summer.